everyone, welcome back. Coming to the next topic in an operating system, that is the page fault. So in previous video I explained you about the demand paging. Okay, so demand paging means CPU demands a page from main memory. Okay, so if the page is not present in the main memory, whatever the CPU is demanding for a page which is not present in the main memory, then you call it as a page fault. Okay, so whenever the page fault occur, what does this operating system will do to handle a page fault? Okay, so let us see. First, operating system looks at the PCB to decide there is any invalid reference which is abort. Let me write that. First, operating system looks at the PCB. Okay, to decide there is any invalid reference which is abort. Invalid reference which is abort. Okay, else if the page is not present in the main memory, then it loads the page, means it takes the page from the secondary memory and stores into the main memory. Okay, just not in memory, load the page. Okay, now how the page will be loaded in the main memory? First, it gets the empty frame from the secondary memory. It gets the empty frame from secondary memory. Okay, then swap the pages into the frame through the disks, means secondary memory. Okay, then again it resets the page table to indicate page. It reset page table to indicate page. Okay, then in memory, set validation bit equals to bit. Now in memory, set validation bit equals to V. Okay, then it restart the instruction that caused the page fault. Restart the instruction that caused the page fault. Okay, so to overcome the page fault, we have to follow the steps. Let us take an example. Okay, so here we take an main memory. So we have to load first M. It sends the reference which it wants to load. Okay, so it sends a reference page to the page table to check whether the page is available or not. Suppose there is I, it means invalid reference. Okay, so whatever it is requesting, that is invalid page, it is not present in the main memory. Then it sends a signal to the operating system. Okay, this is an operating system. As we can see here, the program transfers to the control to operating system. Then the operating system check the PCB. It's check the PCB. Okay, to decide whatever the CPU is demanding is valid reference, is invalid or valid reference. If it is an invalid reference, it is aborted. Okay, and if it is not an invalid reference, then it is not present in the main memory. Okay, then control transfers to the disks, means secondary memory. Okay, if the operating system goes to the disks and requests for the page, whenever it requests for the page, that page will be placed on the physical memory. Here is the physical memory. Okay, it brings the free frames from the disks. After that, these free frames it sends to the page table, because it has to reset the page table When we reset the page table, then only the CPU will understand that the free frame consisting of a demanded page or not. Okay. So after reset the page table, this page table again sends back to the signal to restart the instruction. So again you restart the instruction and demand the page, and again the processor will send the page in a, okay. So in the next time it should be valid now. Okay, so this is new frame, that is demanded page. So okay, so this is how the page fault will be handled. Okay, now let us see in short what it is actually. So first, if you request for a page, okay, it is not present in the page table, then it sends the signals to the operating system. So the operating systems check the PCB whether it is valid reference, or if the page is not present in the main memory, it just asks the DICs to send the free frame. Okay, so then the DICs will be sent to the free frames stored in the physical memory. Okay, so in the physical memory, and then the frames will be sent to the page table, again to the page table. Okay, so whenever the page table is reset with new frames, it sends a signal to the CPU to restart the instruction. Again it means that request for the new page. Okay, so this is all about the page fault. Okay, so what will be happen if there is no free frames? Okay, suppose here the DICs having the free frames, so that's why it is sending the free frames and again storing into the page table. Okay, so but what happens if there is no free frames in the secondary memory? Then at that time we have to follow the technique, that is the page replacement technique. Okay, so in page replacement technique we have to find some pages in the main memory but not really in use. Okay, swap it out and place a new frame in the main memory. Okay, and then same page may be brought into the memory for this several time. Okay, so this is the technique you can follow when there is no free frames are available in the secondary memory. So this is all about the page fault. So thank you.